So again, guys, you're welcome to the continuation of the noble gas, which is group 18. We started with the chemistry concept and line-by-line videos to make you guys understand chemistry in an easier way. I try to come about this as the best method to make you guys understand inorganic chemistry. So that is why I'm getting you guys to get used to understanding each of the elements in the periodic table and how they behave in terms of reactions, some physical properties, and some observations. So about that, we did group 17, line by line plus concept plus past year question. This time around, we are into group 18, which is the noble gases. I know you guys have studied a lot about noble gases in your early classes, but like I do say, you need to watch this video to the end to have maximum knowledge, because there are a lot of things you don't know. There are some you know, and there are some you're going to be seeing for the first time. So let's get started. Don't forget to like, subscribe, and share the content, and comment as well. These are things that keep us going. So guys, we start with the first question. Now, which of the following elements belong to group 18? We've talked about that, a quick concept, which is what we need to do first before answering question, though sometimes we might use the line by line to get answers to question without wasting time. Now, talking about group 18, I told you the last element will be 118. You know that their general configuration is NS2 MPCs. You were told that they have completed their octet structure. So because they've completed octet structure, I hope I can write well in this angle I'm sitting. Octet structure, that means definitely you expect them, they are called noble gases, general name. And maybe I should also make a reference to that. Those are junior classes stuff. They are called noble gases. And because of their octet structure, they are less reactive. They don't even react at all most time. So now, because of the octet structure, and because of that, you expect them to have high ionization enthalpy, or if you like, you say high ionization energy. It is normal. That is the first element on the top. We have high ionization energy. Talking about the arrangement, you know, now I said their general configuration is NS2 MP6, except there's an exception, helium. You guys know helium is just what? NS2. So the members are helium, neon, argon, krypton, xenon, radon. I think radon should be Rn. Yes, Rn. It's chemistry, we have radium, and we have organics. Organics is OG. So guys, keep this in mind. You know their atomic number. I've given you the magic number yesterday about how to get each of these. Now, I said another important physical property we can just quickly talk about is that they are colorless, odorless, and tasteless. All of them colorless, odorless. Permit my spelling. I am a chemist. I'm not what a grammarian, and tasteless. So physical properties. Another important thing you can write about them is that they are sparingly soluble in water. Sparingly soluble in water. Soluble in water. So now mostly this, if you talk about their where we can see them, that is talking occurrence in nature. Most of these are this guy and this guy, they are radioactive. You know, almost all the last two members of every group are radioactive in nature because of their octet structure. So they are not formally said. So the highest amount, argon is mostly seen present in the atmosphere. In the atmosphere. Most of the neon, most of the helium are seen commercially in terms of natural gas. Natural gas. Also with neon sometimes in some cases. So these are occurrence in nature. Talking about rarest, most of the rarest metals are this krypton and xenon. Are very rare. How do you spell rare? R-A-R-E. I hope I am correct. So these are little things I can quickly talk. When I start seeing questions on them, I'll still take you through some preparation. In fact, radon and organics, radon was produced from radium. That is radium. Radium was radium. That is, you can see radium is also a radioactive element. So radioactive element now what by artificial transmutation, or you say by collision. So when it collides, give radon and helium. You can see helium is 4,2. So you can try and get the what's it called, the atomic number of this. It's very simple to get. So I think this is 88, 238. This is 88, 238, if I'm not mistaken. Yes, and this is minus 2 will be 86 and 234. 234 plus 4 is 238, and that you can confirm that as well. So it was actually formed by what? Collisions of what? Artificial transmutation of a radioactive element. So you can be asked a simple question that how is radon formed? Then organics was formed from also what? Bombardment to or collision to as well between calcium and a particular element we call CF. So I think you guys might have learned about this in your junior classes, and if not, the study of periodic table will give you a lot of idea about all these things. So I don't want to waste time on the first question, but I need to talk a little bit about them, and that is why I have to tell you. So most of them, they are not reactive but it was not until a particular year whereby what a particular scientist or chemist, I think in 1875 to be precise, called Neil Bartlett actually bring an idea about how what he was actually trying to work on a particular compound, that is oxygen was combined with all these things are what you can actually learn. That is why I'm giving you with what? Platinum PTF6 minus. So this was positive. So he now noticed that what? That this oxygen is actually behaving, or it's having its first ionization energy. Let me just write first ionization energy as that of what, or very close. First ionization energy or enthalpy, anyhow you call it, is very close to that of, xenon. So he now tried to prepare what? Xenon by changing the oxygen here and mix xenon with PTF6. So, and this particular element or compound rather is studied as what? A reddish color, a red color in what? In just a simple or layman language. So they don't feel what? They don't react. That is their general trend. But it was later discovered by this man that what? It is possible for what? Xenon to react because they have first ionization energy that is very close to about 175 kilojoules per mole. And xenon is about 170 kJ per mole. I'm not going into that because I don't think, unless you're into chemistry major, you are going to be what? Ask that kind of thing. But most importantly, keep this at the back of your mind. Apologies, my bio is actually coming down. I have to pick that up now. You have to just keep all these little things in mind because they are very important. So because of the octet structure, you don't expect them to what? I said they also have because of the octet structure, you can also write this that they are what? They have low melting and boiling point. In fact, you can write this that out of all the elements known in nature up till now, there are 118 up of the time I'm making this video. Are you getting it? Helium is said to have the lowest, helium is He, as the lowest melting point. And that is why most time helium is used as a cryogenic substance. I'm not talking about uses now. We still get to that place, melting point. So this is just few lowest melting point out of all the compound node. You can use that, and that is why sometimes heliums are used as a kind of cryogenic agent, liquid helium to be precise. I think it's about 4 atm or 4 to 7 atmospheric, so which is very, very low. So helium has the lowest melting point. And the reason is because, it is when there is interaction, listen to my explanation, it is when there is interaction between molecule, electrons, and something like that, that you expect something to form a bond. So it's difficult for them to form a bond. They don't form because they have already reached their octet straight or duplex. Idiom we say duplex. I hope I'm communicating. So this particular thing actually is what is affecting them. So we say they don't have any force of interaction. So we say they have low van der Waals force, low Van der Van der Waal. Hope you know what we call Van der Waal force. So because Van der Waal force is acting between their molecule, they won't be able to react to it. So that is what makes them to have low volume, all of them. So talking about those properties of periodic table, we always made mention of, because most questions we ask you, because of octet nature, what do you expect? You expect them to have high ionization enthalpy, right? And one thing about the ionization enthalpy is that what they will decrease as you are going down the group. I want to talk about almost everything in concept first. Decrease as you are going down the group, decreases with increase atomic number or atomic share or quantum share, atomic number. So note that as you are going down the group, you expect ionization energy to be going down. I hope you understand. So they have high ionization energy, high ionization enthalpy, anyhow you want to write it. So these are things you just have to keep in mind for now, because we've talked about their configuration, some of their physical properties, how they are being produced, some little things you need to know. Then again, with time, as I move on, I will still talk more about some other things. So this is a little concept I can quickly break down in terms of what the concept of noble gases. With respect to question, I will be able to talk a little bit more with other things that you need to know, because there are still some reaction, because we talk about xenon was prepared by Neil Bartlett or whatever, and from this particular compound, then he noticed that what xenon can actually react. So it is only this helium, neon, argon that is that they are unreactive. I hope you understand. So xenon combined with oxygen and also combined with fluorine. So to form different type of compound, which we are going to talk about in chemical properties very soon as we move forward. Now, radon, this particular radon, this radon in particular, you can keep it in mind. Also, is not that study, because it was only isolated. It's only a particular compound of radon that was studied. I think it's RNF2. This is the only one that is common to nature. And the same thing also appear is also common to our, it's also applicable to krypton. The only krypton that is known in nature is also KrF2. That is what? Krypton difluoride and radon difluoride. These are the only reactions that is known in terms of radon and krypton. As for argon, neon, and helium, they don't undergo any reaction. I hope you guys are getting all these things. So this is the way I'm going to be breaking down chemistry, so that you can actually get to know them. And when you know them and you are writing down, like I do say, don't assume that you know them. You have to write them down, and you have to have a study time to go through all what you are making, all the notes you are making, because they are very important to go through them. If you want to be a genius, you have to study. That is just it. There is nothing to hide. That is the way to know things. You don't study, you won't know it. So I think we can now move at high speed, like I do say now, because we already have a lot of idea. I hope you have actually jotted down a lot of stuff from what I have said so far. Then we can start picking answers to our line by line question, which will also bring more ideas about what we've talked about. Which of the following elements belong to group 8? So we talk about helium, neon, argon, krypton, xenon, radon, and organics. So place organics. Now, radon, xenon, krypton, answer is what? All of the above. Nothing to talk about there. Concept-wise, you know it now. Next question. Thank you. Now, choose the correct statement regarding group 18. They are all gases. They are gases I talked about there. Then let's pick a red to think. They are chemically unreactive because they are what? They have reached their octet. They only form few compounds, also correct. So some other characteristics you can keep down. So answer to this is also all of the above. The next question. Thank you. Now, group 18 elements are also called, I hope we have talked about halogen and its compound is what we're talking about. So my dear students, I don't think you should have any issues with that. Halogen and compound is what we're talking about. And because it's halogen and compound, so they are called what? Group 18s are called nothing but they are called halogens. I think, remember we've talked about all this. Nitrogens are group 15 for those who are just joining us. noble gases. I said halogens are group 18. Don't mind me. This is our group 17 we talked about yesterday. Group 17, apologies. The noble gases are group 18, which is the answer to our question. And the chalcogens are group 16. We talked about all these yesterday too. So the answer to this question is this. I hope you guys understand this. It's a simple question, which I believe we can move to the next one. Thank you very much. Now, the next question. The next question says, which of the following noble gases don't occur in the atmosphere? I told you it's very simple to know that helium and argon are present in the atmosphere. Most of them are present in the atmosphere. Almost all noble gases, you can write all noble gases are present in the atmosphere. Admin, please don't sleep on bike, as are present in the atmosphere, except the last two members, which is what? Radon and OG organism. So the answer to this is this, and we can now move on to the next one. The next question. Now, about this, we have which noble gas is the major constituent of air? I talk about that. Argon is present in the air and has a major constituent. It's all what present, what found in the what in the atmosphere. The next one. What is the main commercial source of helium? Commercial source of helium, I told you, is what? Natural gas. I talked about that too in the concept explanation. So I don't need to waste time on doing all these things. I think you guys can see the way to answer a question line by line. The next one. Which of the following is or are the rarest element in the group 18? I told you the rarest element in almost all the group should be what the last two members. But in this case, it is what? Radon and krypton. Please note that. Organics is not there because organics is man-made radioactive substance. Please note that. So this is the answer to this. Radon and kryptons are the rarest element of the what? Noble gases. You can keep that in mind. I think I'll talk about that. The next question. The next question says, which of the following compound is obtained as decay product of radium? You can see I told you radium will give you radon and helium. That was part of the concept I've explained in the beginning. This is the answer to radioactive substance giving you what? A noble gas. The next one. Identify X and Y in the given reaction. Just what we did. I told you it will be helium. Just you do your radioactive knowledge, which you have noted, you have learned in your junior classes. So this guy is 88. So if this guy is 88, not shown, but I told you this guy will be 86. 86. It is 88 minus 2 is 86. I'm waiting for this to come up. So you subtract, so helium is going to be formed. So you subtract 2 from this, just like your normal radioactivity concept you might have studied. So this is 86. Still waiting for that to come up. So this is 86. We've already written this 86, and this will be reducing by 4, 2, 2, 4. Then helium will be given here 4 and 2. So it goes without saying radon and helium is the answer to the question. The next one. Now, it said, which of the following noble gas is synthetically produced by collision of Cg and Ca? I told you about these two. I told you it is what OG is produced by synthetic collision of what Cg and Ca. Please note that. So this is the answer to the question. Organism is what is produced by that method. The next one, I'm sorry, I have to rush. I believe this should not be a problem for you guys. Now, this is the way it is being produced, and we'll talk about it. So organism, you know, I told you the last member of group 17 is 117. The last member of group 18 is 118. So even if you don't know anything, organism is produced, and the atomic number is 118. So if atomic number is 118, this guy will be what? 294. Please keep it in mind. And this is the way we produce organism. So this is the answer to the question. We can move to the next one. Admin, please stay up. Let's see. The next one says, which one is a symbol of organism? Organism is OG. We talked about that. The next question. The next question is, What is the atomic number of organisms? The last member of group 18 should be what? 118. It is in the 7th period. NS2, NP6 is the general configuration. Those are the things you need to keep in mind. Next one is electronic configuration of organism. General configuration is it must end with NS2, NP6. Because it's in the 7th period, so it will be 7N2, and 7p6. You know that. So another thing is all that the d orbital is completely filled, you know. So maximum is 10. The f orbital is also completely filled. And you go with what? The closest what? You know what I mean? You go with the what? Closest what? Closest noble gas. The closest noble gas is what we talk about, that radium. So radium plus f orbital is completely filled, d orbital is completely, then ns2 npc in the 7th period. And that is why this is the answer to that. It's very easy with me if you follow the line of my explanation. It's very easy to actually know chemistry. You just have to observe a lot of things and keep it in the back of your mind. Now, which of the following is an electronic configuration of argon? Argon is in the 3rd period. General configuration is NS2 and NP6. Please admit, please wake up. Now, NS2 and NP6 is the general configuration. If NS2 and NP6 is general configuration, argon is in the 3rd period, so that means 3rd period. I'm just giving you some cases, and you have to write the nearest noble gas. The nearest noble gas is neon. So neon, 3rd period, nothing to write on about, nothing to waste time on. This is the answer, my dear admin. Next question. Now, the next question for this should be, waiting, fine. The next question is match the column 1 noble gas with column 2 atomic number. I think this should be very easy for us. It should be an easy peasy. Everybody know neon is number 10. Like, we know neon is number 10. So maybe D, or how do we do it? D is Roman figure 3. They know you know that. Argon is number 18. I hope you still remember that. So neon is number 10. So D is 3. D is 3. Only one has D is 3. Then A is I don't even know how to do this thing now. Admin, are you there? I was sleeping on by. I don't is it this is D is 3. Okay, D is 3. Then A is 2. Okay. A is 2. D, so there's nothing to write again. So B is 1. This one is 36. So the magic number I gave to you, if you still remember, 2, 8, 8, 18, 18, that's 32. This is what you just used to. So if the first number is even 2, the next atomic number will be what? You know, this is number, that is 2, 8, 8. So you have 2 plus 8, 10. Then the next one be 10 plus 8, 2, 8, 8, 10 plus 8, 18. Then the next one is what? 18 plus 18, 36. 36 plus 18. 36 plus 18 are what? 54. 54 plus 32. 54 plus 32 is what? 96. Admin, am I right? Or 86? Now 86. Then 86 was the last 32. That is 118. It is the last number. So these are for your helium, neon, argon. I hope students are getting this. Helium, neon, argon, you have krypton, xenon, radon, and organics. So these are the atomic number in case you need to write them in different ways. So those are the logic to get atomic number of elements in the periodic table. So we move to the next question. So what is the general configuration of noble gases? NS2, NP6, except helium, exception. So this is the answer to that. So nothing to waste time on, my dear student. The next one should be, which of the following statement is not true regarding noble gases? Let's talk about that. General configuration is NS2 except neutral. This is correct. Noble gases exhibit very high ionization energy. I told you because of their, so they don't react. So that means you can see two statements that contradict each other. So definitely you should expect this one to be the answer. To get, they have high level and they what the helium has configuration of 1s2. So this is the answer. So keep this in mind. C is correct to that. Nothing to waste time on. The next question. Noble gas exhibits very high ionization energy due to, we've talked about this. What happened? Because they have stable electronic configuration. Very simple. Last member, all these ones are wrong, wrong, and wrong. Next one. The next question. Now, the correct decreasing order of ionization energy or ionization enthalpy of noble gas is, we said, the first one is helium, and it decreases with what? Helium is greater than, you know what I mean? Helium is greater than the next member, neon. Neon is greater than, because as the atomic number increases, the what? Ionization enthalpy or ionization energy decreases. I hope you are following. So helium is greater than neon. That is in terms of their decreased power. So neon, after neon, argon, krypton, xenon, and radon. So this is the way you are going to, this is what you are going to look. So they said decreasing order, A should be correct. I hope you understand. I told you don't make mistake, because anybody can actually make mistake in terms of inequality sign. Just, in fact, you may know it, but if you are not careful about the inequality sign, you might actually fall a victim of what? Mixing those type of questions. Now the next question says, which of the following is true regarding the ionization enthalpy of noble gases? I told you they what decreases down the group due to increase in atomic number. Direct statement. Decrease down the group with decreased atomic number is wrong. Decreases down the group with increased atomic number, 100% right. So this is the answer. I don't need to read any other option. I move to the next one. I hope I'm not too fast. The next question. The correct statement regarding atomic radius. Now, we can quickly talk about atomic radius. We know the way atomic radius behave. I think I've talked about atomic radius increases. Atomic radii. Radii means it may be more than one. Increases down the group. Down the group. Due to increase in, I think I've talked about this to admit, due to increase in atomic size or atomic number, atomic size. So that's just that. So which of this is increases down the group in increase in atomic number? I don't think we need to waste our time, to be honest, because I think we are getting this thing because what you listen to the what few minutes of concept before I start this. Now let's move, because we still have about 70 questions to talk about. So we need to move on. The correct order of atomic radii of noble gas is what? You know, the increases down the group. So you should know that what helium is less than. So it will start from the last member. So it should be xenon is greater than krypton, greater than argon. You understand? It should be the opposite of what? The ionization enthalpy. So that is the answer to this. Just start from the one that is on the ground, then you move upward. So the next one, noble gases have dash. Now, large negative value of electron gain enthalpy, large possible value of electron gain enthalpy, low negative value of electron gain enthalpy, low positive value of electron gain enthalpy. Maybe I didn't talk about this. I think it's talking about electron gain enthalpy. Noble gases, they have octet structure, except helium that has duplex. Octet structure. Now, because they have octet structure, you don't expect them to lose or gain any electron. So we say they have large positive values of electron gain enthalpy. The stuff is not writing again, admin, as I'm calling you, of electron gain. I think it's loading of electron gain, because they don't undergo in reaction. I told you, kind of van der Waals force. It is what reacting between them. Yeah, it will come up. So you don't expect them to react. So that is the way it is. So this is positive electron, large positive electron gain enthalpy, because they already form stable structure. Enthalpy or energy, anyhow you see it. So please note that. So this is the answer. No, not negative, large positive. So this is the answer, my dear student. So guys, I hope you are getting this thing. And the reason is because no interaction. There is no interaction. They have what? Van der Waals force between them. So the next question. Now, noble gases have large positive value of electron gain enthalpy because of they have what? Stable electronic configuration. I talked about that. They are stable. They have no tendency to accept electron, which is the same thing as the language of the first one. When something is stable, they don't accept what? Electron. So the answer to this is both A and B. They have high tendency. They cannot. When we say they have no tendency to accept electron, you can say they also have high tendency. They look simple because you are following it line by line. And that is the exact thing I do say. watch the video to the end because you are still going to see some other thing. Maybe you don't have a full idea about them, which you are going to learn. So for maximum knowledge, stay with us on this page and make sure you subscribe and like the page as well. Choose the correct statement about noble gases. I told you they are all what? All gases are what? Divalent except noble gas. I do say that in my offline classes many, many times. So I say all gases are divalent except noble gases. So noble gases are monovalent. So they are monovalent. All noble gases are, no, it's wrong. All noble gases are except all of them. None of them. So the answer is what? This guy. So I hope you understand the simple explanation of ours, and that is the way we move. On to the next one. The next question. Apologies. Thank you. Noble gases are, I gave you physical properties. I think we are now on physical properties. So noble gases, I said they are colorless, they are odorless, they are tasteless, they are sparingly soluble in water. So all of the above will be the right answer as per this question. On to the next one. The next question, line by line, concept plus past year questions. That is what we are talking about. They are sparingly soluble in water. Is it a property of noble gases? I think it's a yes. Yes. They are not soluble in water. It's a no. They are sparingly soluble. They have low melting point. I talk about that. They have low boiling point, physical properties. Among the given, which is true of noble gases. Admit did not finish this question. So what is true is Roman figure. I think this is Roman figure 1. Then Roman figure 1, Roman figure 3, and Roman figure 4. So this is the answer to the question. These are properties, low melting point and boiling point. Helium has the lowest melting point out of all the elements. So you get to know your elements if you study the periodic table, and that is the essence of starting the concept of chemistry with studying. So when I will do carbon next by the grace of God. After carbon and its compound, I'll do hydrogen, and I'll give you some intro to organic chemistry, talking about general organic chemistry. So stay tuned and be helpful by helping us to share this content so that it can reach a lot of people who are actually suffering or having some challenges in chemistry. The next one says noble gases have very low melting and boiling point. The reason is what? I talked about this, right? Weak what? Dispersion force. Happy? Weak Van der Waals force, weak dispersion force. So please note that this is the answer to this question. They don't react, so they are not moving. So there is a weak dispersion force in between them, and that is why they have low melting and boiling point. On to the next one. Thank you. Now, we say the increasing order of the melting point of what? The noble gases. I told you helium has the lowest melting point. So helium is lowest. So if helium is lowest, you know what it means. That means the highest is what? The highest is the last member, which is radon is greater than, you know what I mean by that? Radon is greater than, that is what you need to understand. That is in terms of what? Their strength. So here they're saying increasing order. That means you start from the lowest to the highest. So you start from helium. Are you there with me? Helium lowest to highest. Helium is less than, I think. So this is not having helium. After helium, you have neon. So neon is what? Argon. Then argon is krypton. Then xenon. Then radon. So they said in the order of what? Their lowest. So it should be helium, neon. So the inequality is always a problem sometimes. You need to understand inequality. So if helium is the lowest, then you are doing it increasing. So helium is less than neon, is less than, that is what I'm trying to say. So it's less than, so that means in what we are saying is that neon is greater than this is greater than this. So you have to be careful about the aspect of inequality sign so that what you know in language form will not cause problem while picking this. So the next one. Thank you. The increasing order of boiling point is, you can see both they have low melting and boiling point because of weak dispersion force or forces. We did something like increasing order of melting point, which will also be the same thing as that of boiling point. I hope you understand. And this is the answer. So the next one. The next question is, which of the following element has the lowest boiling point of any known substance. So the answer is what? Helium has lowest melting and boiling point. Boiling point in particular, please note that. So helium will be the answer to this. So next one, we move. The inertness of noble gases is attributed to dash. Everybody should know this. All properties stated there should be correct because noble gases, they have completely free their what electronic configuration. The noble gases have high ionization energy or ionization enthalpy. Noble gases have more positive what electron gain enthalpy. Then the answer will be what? All of these listed stuff. So now the next question, the next one. The next one is now, who observes the reaction of noble gases first? I think I talked about this too. That is, it's not about Stein or Plato. It is one Neo Bartlett. So that's the answer to the question. I talk about that if you are following, and I think it's time for us to talk about his observation, which we are going to be talking about some other concept very soon. So now we are getting to some reaction of xenon because he used xenon to prepare his what? His compound. So let's see how it goes. The next question. About the next question, we have, thank you very much. What made Neil Bartlett to prepare Se plus PTFC minus? Now, in notice, I told you that the ionization, first ionization energy of oxygen is similar to that of what? Xenon. So the first ionization energy of O2 was almost identical to xenon. Language, what I said exactly. So, and this is why you need to what? Be careful, take note of observation when you are reading chemistry. Because chemistry is more of what? Observations. Observations. So I hope you are enjoying this section. The next question, admin, I want you to know, I hope I am very close to the end of this stuff. Now, I'm at slide 171. So I don't know where I'm going. It is my admin that always pick question line by line. They are really doing a good job. Kudos to them. So I see about to 30 more at admin. Oh my God, admin said we are going to 214 slides. So that means we still have a long way to go. Now, what two compounds were mixed by Nebartlet to prepare the red color compound? I thought it means what is xenon with what? PTF6, direct thing that we've talked about. So I don't think we have to waste our time on concept we've talked about. The next one, the next question. The next question here is Mosdi Academy. Now, with which of the following elements the xenon form a number of compounds? Now, I told you most noble gases don't react, but xenon do react with oxygen, and this guy xenon also reacts with fluorine. Maybe we talk a little bit more. Xenon can combine with fluorine, direct combination in different way. Xenon combine with chlorine, F2, to give SeF2. You can listen to quick concepts again, because concepts are very important. Xenon can also combine with chlorine. There are three binary fluorides. That is ZeF4. And the last one, xenon can combine with fluorine to give you ZeF6. These are what we call the binary compounds. They are three. This is with excess chlorine. Excess chlorine. At a temperature of about, I think this temperature should be about 343. I am not sure. But when I see options, I'm very good in that. That's one thing about me. I think about 373 Kelvin. That's one thing about me. I will tell you, and about 1 bar atmospheric pressure. So this is with SS fluorine, SS xenon, SS xenon, please, not SS. Oh my word, my app is still loading, so I have to wait for this thing to come up. So this next one is a kind of reaction that takes place in a kind of temperature that is a little bit what higher than the first one. So the temperature at which this one will take place is at about 573. And this one is about temperature that is lower than these two. I think it's about 300. I think this is 313, 513, and this is about 213. We shall see that as we move forward. So, but always keep in mind, xenon combined with fluorine, and they also easily undergo hydrolysis. You know what hydrolysis means? Adding water to them, and that is where oxygen comes in. So, this xenon, SeF2, xenon fluoride, they easily undergo hydrolysis, all the three. So quick concept you can just keep in mind before we start speaking answer. Now, when ZDF2 undergo hydrolysis with water, Now, there's another way in which we can prepare this guy, this SeF6. We can prepare it from what? This guy. These are SeF4. That is a xenon tetrafluoride. To pronounce this should not be a problem. When it is mixed with, I talked about the oxide of fluorine yesterday when we did halogen. That is O2F2. O2F2 at about 143 Kelvin. That's the temperature that is needed. You are going to have SeF6. So there are two ways of preparing SeF6. Either by the temperature of about this and by increasing the atmospheric pressure. Atmospheric pressure is raised. You can produce this. SeF2 is just excess of xenon combined with fluorine. At their main place, watch what I'm doing because I don't want to have any lag. That is why you are needed, please. Thank you very much. Now, when the temperature is now reached about 513 to 573, thereabout, you are going to have what? SeF4. Then when the fluorine is now raised, the temperature is lowered, but the atmospheric pressure is raised. You have SeF6. So now there's another way in which you can produce SeF6, combining SeF4 plus O2F2. I told you there are two oxide of fluorine, O2F2 and OF2. Remember that yesterday? Yes, very good. Where I talk about plutonium. That is, we use O2F2 to extract plutonium out of its compound. These are things, observations are very important. And you have to write. Because if you are not writing, it will be difficult. So hydrolysis of XeF2 is very simple. It's going to give you xenon on its own. It's going to, you can balance equation. Everybody should be able hydrogen fluoride, and it's going to give you oxygen. So these are the products of hydrolysis of SeF2. But when you hydrolyze SeF4 and SeF6, be careful. You can generally, you are going to produce another oxide. That is where oxygen are coming. You are now going to combine what we call oxy acid. That is this is a common product that is common to two of them, SeO3. So it's a common product that is common when you hydrolyze this remaining two binary fluoride hydrolysis of these two. They both are going to produce SeO3. So the major reaction you study later is xenon, because it was what Bartlett used. You understand? He combined it with oxygen and stuff like that. So now these hydrolysis of SeF4 and SeF6 can now be partial and what fully. So we can have partial, SeF2 is very simple. This is what we are going to liberate directly, nothing more pretentious. But when it comes to SeF4 and SeF6, they both have this common product of SeO3. Please keep that in mind. In fact, we can talk about the shape, which I will still talk about. The shape of this guy is a pyramidal, because it has one lone pair. I can draw the structure from our knowledge of VSEPR. If you don't know that, stay with me. I will teach you all those bond pair, lone pair, VSEPR structure. Those one will not take me up to 58 minutes to teach you how to calculate all those things. And you are going to understand it very well. Lewis dot structure and stuff like that. Now, about what I'm talking about, when you now hydrolyze this, when you hydrolyze SeF4 partially, look at it. Partially means you can actually add 1 mole of water to it, or you can add 3 moles of water, you can add 2 moles of water. What happened in this type of reaction is that the amount of water you are adding to this guy, SeF4, let me just say, plus 2H2O, is what determines the amount of hydrogen fluoride. This is 2 times 2. You will now say 4HF. I just want to teach you guys how to get this. So you can see it is 1 times 2. That is 2HF. So that is how to write the equation of the hydrolysis. Then plus what is remaining. You have taken 4 of this one. Then you have taken 4 of this one. You can see 4 of this one is gone. Then you have taken 4 of this one. That is Se. You have this is only you have taken 2 of this one. So the main Se for this one, Se, admin, are you there? Se, then F4, F2 is gone. You have FO, F2. You can see SeOF2. That is what is left here. I hope I am right. 2 of hydrogen is gone. Hydrogen is no more there. Then 2 of fluorine is gone out of 4. So what do you have? You have fluorine 2 remain. Then the oxygen here. Then that is how the oxygen atom of what? Of xenon reacting with oxygen coming out. So all these things are very important for you to keep in mind because you are going to be asked questions on them. And these are how we come about them. Xenon is the major one that we put into study. I told you both for radon and krypton, the only one known is what? RNF2 and KRF2. But for xenon, they react with oxygen and with fluorine to form all these type of what the action that I've talked about. We talk about them, taking question on them line by line. When you see question of them, you are going to understand them better. So let's move on, guys. Then the next one says, with which number of elements is xenon form number? It doesn't react with this. I told you now, just now. It's only with fluorine and oxygen. So answer to this is this. I hope students understand that. Let's move with high speed. The next question, admin. Thank you. Which compound of krypton is studied in nature? I just talked about that. KRF2, only KRF2. So what is that? It is at D. Answer to that is that. Next question. This is Mosdi Academy, line by line concept plus PYQ. Watch the video to the end for maximum knowledge. You know, I do say that. It's very important. The only compound identified for radon is also RNF2. I hope you are still following the same thing. So question answer, we move forward. The next question, you can see the way I'm doing chemistry. That's why most time when I solve chemistry, I just tell you, I don't need to waste time. Let's move on. Now, what was the color of the first compound? I think that was what we talked about. That and color red. So that was the answer to this. We can move forward. Next question, please. How many binary fluorides do we have? SEF2, SEF4, SEF6. So there are 3 of them. I talked about that in the concept just now. So let's move on. Line by line chemistry is the best way to understand chemistry concepts without any problem. So then you put down stuff. The next one. The next question here is, which of the following binary of fluoride is not known? SCF2, SCF4, SCF6. We know this, we know this, we know this, we don't know this. So this is the answer to the question. There are 3 binaries of what? Of fluorides with xenon, which we have talked about. Next question. Now, this is the time you have to be careful. Look at this now. What are X, Y, and Z in this? Let me expand this guy for you guys to see and move it here a little bit. I hope you can see it very well. Now, this is what we are talking about the other time in terms of the concept. I told you about something. Look at this now. SEF2 with SS xenon. What are you going to have? About 673. You can see 673 and 1 atmosphere, 1 bar. You are going to have SEF2 because SS xenon. Now, here, if the ratio, okay, I need to actually let you know the ratio also are very important. If you are mixing it in ratio of 1:5, please keep it in mind. You are producing SEF4. But if the ratio is in 1:20, very good, you are producing what? SEF6. It is in order here. You can see the temperature is raised and the bar is also raised. So this is SEF4. So when the bar is not very high, like I said, and the ratio is 1/20, SEF6. Keep this in mind. They are very important. And you go for that. SEF2, SEF4, SEF6 is the question answer. I hope students understand this. These are simple stuff. Let's move on if you have learned them. So the next question. Thank you. Now, what is the temperature and pressure of SEF2? Because this is where something is. Now, it is 1 bar. Remember, what I know is that it is 1 bar. So I'm very sure about the atmospheric pressure. So 1 bar and what? And 673. Objective question are simple to know if we read line by line. The next question. The next question is, what is the temperature and pressure of the condition required to prepare xenon tetrafluoride? That is SEF4. Now, what happened? The bar is raised. So because the bar is raised, and the temperature is also what? It's also, the temperature is lowered, I guess. The temperature is lower. Is it lower? The temperature is raised too. So it is 873 and is it 873 and 7 bar? I hate speaking wrong answer. Let's check that. But I think it's 873 and 7 bar. I know the bar is raised to 7, from 1 to 7. But the temperature is what I want to be sure of, because all these things, I will go for C if I'm picking. That is what I will pick. That's one thing about me. Let's show it from here. I think we have it in the question here. 873 and 7 bar. I know the bar very well, so you can see absolutely correct. 873 and 7 bar. So that is the answer to that. And the ratio is what? 1:5. So that's what I will go for, because I know the bar. I know the first one is 1 bar. The second one is 7 bar. That's what I study very well during my time. And the last one is 60 to 70 bar. And I know the temperature is lower. And the last one. So the next one is, those are my own way to actually know something. So the next is, next question, please. Okay, now what is the temperature and pressure condition required to react XeF6? Now we just look at that one. You know it is 60 to 7. That is the highest bar. Then you know the ratio as well. So, and the temperature is lower to 573. So 873, 673, and the last one, admin is really sleeping on bike here. So now, and the last one is 573. So that is the answer to this. And we are actually getting to the aspect that you need to pay attention. So the next question. So to the next one. The next question is SEF6 can be formed by interaction of dash and dash. We've talked at this temperature. So I talk about another way in which SCF6 can be formed. I said it can be formed by what? From SCF4 plus O2F2. Do you remember that? I hope you still remember that. That is another way, 143. I've talked about this in concept explanation, and I think that should not be a problem. That is very simple to key like that. So that is very simple, and that is the right answer to that. So the next one should be the next one. I'm waiting for this to load. Now, what is X in this? That is SEF4 plus O2F2. We give you this and this at a temperature of 143 Kelvin. This is very, very important because it's one of the fundamental reactions of what? O2F2, which most people don't even know it exists for what? For fluorine. Please keep that in mind. I can tell you. So the answer to this one is SEF4, and we can move to the next question. The next question is slide 184. Most the academy noble gases concept demystifier. So knowledge propeller. So you just have to stay with us to get the best. Now the next is hydrolysis question. We've also studied hydrolysis question. I said SCF2 is very simple to hydrolyze. That is, you add water to it. What are you going to have? Sc will come out, hydrogen fluoride will come out, and oxygen will also come out. So you just need to go with that. Where is that one? This is the answer. That is that about that. To balance equation. I hope all my students here can balance chemical equation. So the next one is just what we talk about. You can see an oxygen. So what's this? SEF2, right? SEF2 hydrolyzed to give these three stuff. So the answer to this is choice C. I don't need to waste time. Slide 186. We are almost there. Now, what is the shape of SEF2? Shape time. Now let's talk about shape time. SEF2 is having, we can use the knowledge of VSEPR, valence share, VSPR, the way people call it, valence shares electron pair repulsion. Now, there's no much repulsion. Xenon is going to have its NS2 NP6, 8 electrons. So if you draw that, it's simple to know. Then 2, fluorine is 1, 1, 1, 1, 1, 1, need 1 electron. So if you say 8 star, the knowledge I used to teach, 2, 3, 4, 5, 6, 7, 8. You can listen to concept. Then if you take away fluorine, the first one, there are 2 fluorine, 1 and 2. So 1 and 2 is gone. So what are you having left? So you have 1 lone pair, 2 lone pairs, and 3 lone pair. So you have 3 lone pair and 1 bond pair. So 3 lone pair and 1 bond pair will give you, and again, you can draw the structure to give you a linear shape. So linear shape is the shape of SEF2. So you can draw it. It's very simple to draw. Sc will be at the middle. The most electronegative substance always stay at the middle. Then you can draw the fluorine and fluorine here, and start drawing your 3 lone pair anywhere you want to draw it. So you have, or you place your F and F here, then you draw the rest by the side. So that is how it is being drawn, and that is a linear shape. So the linear shape is for SEF2. You can keep that at the back of your mind. On to the next question. The next question is good. The shape of SEF4. Now about SEF4, you are taking 4 as 2 bond pair, 2 bond pair, 2 lone pair. Because it is 2 bond pair, 2 lone pair, it's going to give you a square planar. So that means Se will stay at the middle. Then your fluorine will now stay like this. So please keep it in mind. This is the way it is being drawn. So then the lone pair will now stay at the middle. One here, one will do lone pair, and the other one there. So that is the way SEF4 structure, the way it looks like. So we say it is what? Square planar. So That is like a square, a box. So that is the answer to this one. So the next one, please keep note of all this. These are major questions you see. Then the number of bond pair electron and lone pair electron, bond pair and lone pair electron in XeF6. Xenon is 8. Just draw 8 stars because xenon is what? A noble gas. 8 electron field. So draw 8 stars. This is the logic. I do tell students. Very simple. 1, 2, 3, 4, 5, 6, 7, 8. Fluorine needs 1 electron. So each of the fluorine will carry 1. So 6 of them is going. 1, 2, 3, 4, 5, 6. So that is 6 bond pair. So that you have bonded 6 atoms, then remain 1 lone pair. 2 of a star. 2 star is 1 lone pair. And that is what? 1 lone pair. So 6 bond pair, 1 lone pair. Question answer. I hope you are getting chemistry. Chemistry is not that hard. It only needs interpretation and understanding. And that is why I asked you to watch the video to the end for maximum knowledge. So guys, on to the next question. The next question is question 189, slide 189. I don't know the question number. The next one is which of the following is the shape of SeF6? The last one. SeF2 is linear. SeF4 is what? Is quaplanar. SeF6 is said to be what? Distorted octahedral. Why is it distorted? Because it can only be seen in gaseous form. That is the distorted pattern. Now, if you draw it out, that is what you are going to have. It's going to give you a distorted, I think it's sp3D3. That is the hybridization. You can keep it in mind if you need it, hybridization, because you need to know almost everything in chemistry to be a very good chemistry student or scholar or even a teacher. So the shape of XeF6 is distorted octahedra, the way I call it in offline classes. So that's the answer to that. Nothing to talk too much about here. Excuse me, I'm dehydrated a little bit. So the next question. Now, on to the next one. The next one, we are almost there. Admin, this is slide 190. I hope I'm almost there. Thank you very much. Now, the next one says, which of the following is or are fluoride acceptor? Now, when we say fluoride acceptor, please be careful about this. Now, one thing about all these stuff is that when the fluoride of xenon combined with all these X fluoride, what we see is that they donate their what? Their fluoride. They give F minus to all these ones, either phosphorus pentafluoride or antimony pentafluoride. This is what I'm saying. If we have SeF2, for example, combining with PF5, are you getting it? What we see is that this guy is going to lose one of his these fluorine. He's going to lose it by having, you now have SeF, it is F2 before, you have SeF minus, then plus the fluorine has now been donated to this PF5. Admin, are you with me? It will now be PF6, then this one has gained. So this is a common reaction of xenon in terms of electron acceptor and electron whatever. So be careful about that. This is the way they be. So we are talking about the one that what accept electron. In this case, this guy is giving electron. This guy is what is gaining electron. So we have to be careful which of the following is or are fluoride acceptor. So this guy accept. So from this guy also accept. Then look at this one. If you combine this one will be this one do not accept. So I think the answer should be A and B. So please be careful about this. It should be A and B and not all of this. I don't think there's any option that is correct about that. So please note that. The next question. Now, which of these following is not a fluoride donor? So the one that will not donate here should be the one that is here. You understand my point? So now we are talking about the one that we accept, rather. The one that we accept out of this one should be, I talk about metal. This is RB. My stuff is hanging. SeF2, SeF4, SeF6, they give fluorine. All those ones give fluorine. So which of them is not a fluoride ion donor? This is donor. So the one that will not donate, this is the answer. This is out of it. So please, because this does not combine with what's it called, with fluorine. Please note that. Now, it's combined with fluorine, but it does not donate. That is what we are talking about. It's combined with fluorine, halides. We've talked about that yesterday, don't forget. So that is the answer to the question. All these are going to what? They can release their fluorine, and what? Others will what? Others will gain. So the next one, the next question here should be, what is the product, what is product P in the given reaction? Just what I explained the other time. What happened? This guy is going to give his F to this guy to make what? PF6. Are you there? So, and this one of these thing is gone. So you expect SEF plus and PFC is what? Minus. I hope you understand that. That is what I was explaining to you the other time, and that is how they react. So be careful about that type of question. Next, that's why because we know fluorine is what? F is what? A fluorinating agent. The way I spell fluorine sometimes, fluorinating agent. We talk about that also under the concept of halogen and its compounds. Oh, heavy heights, my admin. Don't sleep on bike, please. The next one. The next question is the same reaction. What happened? This guy is going to give one of these this thing to SB. And this was what I was trying to say the other time. When this one remain 3, that is SEF3 minus and SPF6 plus. I hope you understand. So correct answer SCF3 minus then SPF6 plus. You can see this is the one that is gaining, and this is the one that is also, this is the answer. So the answer to that question is this. So please just note the way I am getting them. This will lose one fluorinating agent, then this will lose one fluorine, then this will what? Take the fluorine. So that is the logic. The next one, we are almost there. Almost there. Now, in this reaction, which we just talked about, you can see this guy is going to lose, and this guy is going to gain. That is with MF. So xenon hexafluoride is what? It's we can just calculate the oxidizing agents. That's just what we need to understand here. So to know if it is a xenon, this is the one they're asking. At the end of the day, this is 0, then it is going to -1. It is reducing. So it's a powerful oxidizing agent. So that's the answer. You know what I did here? From 0 to -1, it has reduced. Reduced means oxidizing agent. So now it's an oxidizing agent, but we are talking about the reaction here. Sorry about that. This is wrong. So we are talking about fluoride ion acceptor and fluoride ion donor. We should be careful. So let's be careful about it. In this case, what happened? SCF6 has now what? Accept. You can see it has accept an electron to be what? SCF, so it's a fluoride ion acceptor. This is the answer to this question. So please, not an oxidizing agent in that reaction. Fluorine in that xenon and fluorine, you expect what? A donor of fluoride or an acceptor of fluoride. Fluorinating agent. Please keep that at the back of your mind. On to the next question. I am rushing now. We are almost getting there to the end of the question. Then it's about hydrolysis time. Which of the following is a common product of this and this? I told you SEF2 will give you Se plus HF plus O2, but these two guys always give you SeO3. I've explained that in concept if you are following me line by line. The next question. The next question says, what is the product obtained on the complete hydrolysis of SeF4? You can see complete hydrolysis, SeF4. Complete hydrolysis. I told you SeF4 will definitely give you SeO3. So you expect oxygen 2, you expect hydrogen fluoride, then you expect xenon. Xenon, hydrogen fluoride, just write plus, 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 and this. So this is when you completely hydrolyze is with water. I think 4 molecules of water. You expect xenon, you expect hydrogen fluoride, you expect oxygen, and the common product between SeF4 and SeF6, SeO3. So you look for something that looks like this. Option, please. This guy. So this is the answer to the question. I hope you guys are following. Don't sleep on bike, please. It is dangerous now. Now we're almost there. How many slides am I going? This is 197. Where am I going? So we have 214 or what? Now 197, I still have about 16 to 17 question more. What are the products obtained by complete hydrolysis of SCF6? So when you what hydrolyze SCF6, yeah, very good, with water. That is with 3 moles of water. That is complete hydrolysis. So you have 6HF. So you have 6HF plus 6 molecule of fluorine and water. Then I said it should be SE. I said 6HF. It's not 6HF. It should be 2 complete hydrolysis. So if we go by that, it should be SE. No, 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 no. Let me balance the equation. Apologies. Eraser. Okay, this is it. So complete hydrolysis. So if I hydrolyze, is adding of water that we understand very well. So it depends on the amount of water I add to have complete hydrolysis. But what I'm going to have, complete hydrolysis, please. Complete hydrolysis will give me Xenon plus SeO3. We say it is common to both SeO4 and SeF4 and SeF6. Then plus hydrogen fluoride. Please note that. This is the product of complete hydrolysis. You have to balance the equation, which I believe you can all do. So this is the reaction for complete hydrolysis. Complete hydrolysis of xenon hexafluoride. So I go for what as this. So this is the answer. So please note that that's the correct answer to the question. The next one. The next question is the number of mole of water required to complete hydrolysis of xenon hexafluoride is dash. That is what I'm trying to say here. The number of mole of water here is 3 because you have 6 here. So keep that at the back of your mind. So we use 3 moles of water to balance a complete hydrolysis of, because you have to complete the total number of what you have here. And you know, if you want to complete, you have to balance the equation. But we use 3 moles of water for complete hydrolysis. So the answer is 3 moles of water. The next question will be in the next slide. So the next one, partial hydrolysis of XeF6 will give you can write this quick concept. Partial hydrolysis of XeF6 will definitely yield oxides and oxyfluoride. So that is what we are talking about. If it is now XeF6 plus 2 moles of water, you are going to have SeOF4. Please note that plus HF plus O2. So this is incomplete. So if it is with 1 mole of water, it will be SeO2F2. That is another thing. So these are incomplete hydrolysis. You can keep all these reactions plus H2O 1 mole to now be SeO2F2 plus what? This is now what we call, this guy here is now what we call oxyfluoride. You can say oxyfluoride. So note that. So it will yield oxides and oxyfluoride. So that is that. Keep that at the back of your mind. So the answer to this will be both B and A. And we move to the next one. Almost there. Please, guys, I have to increase because I still have used this. Now, identify X in the reaction. You can see so far it is 1 mole. I don't need to disturb myself. If it is 1 mole, that is why 1 mole is combining here. Do you understand? 1 mole. If it is 2 here, what will be here will be 2. Those are the logic. So what is here is 1 mole. So if you put 2 here, you know this one has gone. So just be careful to know that if one of this is gone, one of fluorine is gone, what do you have left? Okay, this is H2. Sorry, this should be 2. Apologies. This is not writing at me. Wow. It is loading. That is why I have to wait there. Students, I have to wait for this loading store so that I will be able to write and balance the equation for you. That is 2 molecules of water. So we have to follow the line. That is partial hydrolysis as we have explained. I think it's back. Hopefully, it will be back to normal. So I am having SeF6, please listen, plus 1 molecule of water, which is a partial hydrolysis. So I told you always write HF first. The number of hydrogen that is here is 2. Remove that first. What do you now have? You have 4 hydrogen is gone, and 2 fluorine is gone. So you're having, it's a simple way to write hydrolysis reaction. That's just a simple way. Se, yes, then F4. 4 hydrogen is 2 hydrogen is gone. So no more hydrogen. 2 fluorine is gone. Remain X4, then oxygen. So OF4. I hope you guys understand what I've done. So that is the logic on how to know answers to partial hydrolysis of SeF6. The next one, fine. 2 molecules of water, the same concept. SeF6 plus 2 molecules of water will give you, first of all, complete HF. What do you have here? 2 times 2, 4. Then the remaining compound will now be here. Admin, please. We have SE is here. Then what do we have left? I just want you to count with me. I don't want to make any error, any mistake whatsoever. So SE, I'm counting the remaining stuff. I've taken 4 fluorine, remain 2 fluorine. So then again, I have 2 oxygen, that is SeO2. I think I've written this reaction before the other time. Then I have remaining 2 fluorine, F2. So this should be what I will have as my X. So this is the answer, O2F2 is the answer. So that is that. So complete hydrolysis, you know what you are going to have. Se2O3 will be there. Incomplete hydrolysis will give you SeO2F4, SeOF4, and SeO2F2. Don't need to cram. Know how to balance. If you know how to balance, the logic is just count the amount of water. First of all, balance the hydrogen fluoride. When you balance hydrogen fluoride, the rest is what? Very easy to do. So it is an easy peasy. So the next question, we are almost there. 214, right? Okay, thank you very much. Now, which of the following xenon compound is colorless explosive gas? Let me quickly give you concept of SeO3. Number 1, it is colorless. Number 2, it is explosive. Number 3, you know this is formed when you have complete hydrolysis of SeF4 and SeF6. Watch this video to the end because it will really help you. It is explosive. Then again, it's sublimes. So keep these 3 in mind. It's very important. So which of them is explosive solid? Then again, all the 3 binary fluorides of xenon are solid. SeF2, SeF4. You know, we've talked about them too much. And SeF6. They occur in what? In solid state. Please note them. So SeO3 is also solid. Not be liquid, please. It is not a liquid. Please keep that at the back of your mind. So this is the answer to this. These are other products that are formed. These 2 products are formed where? As a result of what? Incomplete hydrolysis of SeF6. There are different ways you can produce SeF6. 2 major ways. It can produce as SeF4 plus what? O2F2. You know that we talk about that. So, and the other way is by what? The one in which you will raise the atmospheric pressure and also the amount of the ratio of what? Xenon to fluorine. Do you understand? So, guys, I think we are almost there. So now we go to the next question. The next question is the shape of SO. I didn't talk about shape of it. You can also do, I think I've talked about this shape. Yes, I talked about it, which I told you pyramidal. Yes, I told you it is pyramidal. Because it is what? sp3ib, that is 1 lone pair. And it has, because it has 1 lone pair. You can draw that if we want to draw. It's more like your ammonia shape. So it is a pyramidal. This is the answer to that. So the next question. Now, the wrong statement regarding SeOF4 is that I told you all the fluorides of these things, they are what? They are solid. They are not liquid. So anyone, it has a pyramidal shape. It has a it is a volatile, the wrong statement. This statement is wrong. It is not a liquid. So this is the statement that is wrong. This is correct because the shape of this guy is also pyramidal in shape. So that is the answer to that. This is the answer. It is a solid, it has this shape, so it is not a liquid. The next question, the next question, the next question. The number of lone pair present in SEF2, I think we did it the other time, but I can't remember. So I always love to draw. It's simple to know. Out of 8, xenon is 8, group 18. So 8, you have taken 2. Out of 8 remains 6. How many pair can you form in 6? 3. So the guy has what? 3 lone pair. Do you understand? Simple method from the concept I've explained the other time. So this is the answer to your question. The next question, again, let me know if I'm very close to it. The number of lone pair on the central atom, of all these guys have central atom lone pair of 1, 1, 1. Nothing to talk about. There's a simple thing. Concept of VSCPR. If you don't know it, I'll definitely help you break in that in a particular video. So answer to this is just 1, 1, 1. And I think I'm almost there, 214, right? Then we have helium I think we are now in what some physical properties and uses of what? Helium is a very, 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 very light gas. I hope you know that. I think I've talked about that. Helium is very light. It has a very low boiling point among all the elements. We expect helium to have a low melting point because of a low dispersion force. Is that not it? Very good. So now it is also what helium is not flammable. How can it be flammable? Say something is noble gas. It's not reacting. It is only xenon that we study. If you notice, we only study xenon, because that's the only one that the Bartlett discovered. You understand? And that is why that's the only one you need to know. In any standard exam, that is the only one you can be asked, even to the level of the JUPEP, because this video is not only for O-level students. We are taking it to O-level students can also learn it in what? Completely, because it will help you and increase your knowledge and understanding. So this guy is correct. This guy is correct. It can never catch fire. Note that helium is so this is the answer. Both A and B is correct about the properties of helium you have talked about. The next question, almost there, 208. Helium is used in filling uses now. We are now in uses. Now, about uses, we use what? You can keep all these small notes down because, wow. Because I think this is common for UTMA student and YX student. This is what you see everywhere you go. Heliums are used in filling balloons. And they are also used in meteorological observations. Filling balloons because helium is light. And it is what? Non-flammable. We just talked about that. So that is the reason why we use them in this process. So one of the use of helium is filling balloons and for meteorological observations. Some helium are also used to separate some radioactive substance. Maybe for now, I won't talk about it, just focusing on what is needed. So B and C is correct for this one. I hope you guys are still with me. We are almost getting to the end of this section. I hope you guys are actually writing all these points down because we want to improve the level of chemistry in our country. And that is the essence of doing all these type of videos. Now, the next one is liquid helium is used as dash. I think I talked about this. So liquid helium is used as what? A cryogenic agent. I talked about it at the beginning. I still remember. Admin, can you be a witness? I talked about the cryogenic agent. Now, what is cryogenic agent? They are agents that are added to a what? In the extraction of they are agents that are added to another property or another substance to lower its temperature. That's the way I can help you put it in the simplest form. So liquid helium, because it has low boiling point. You remember? Helium is having low boiling point. So that is why it is used as the cryogenic agent. So this is the answer to that. So another use of helium is what? As a cryogenic agent, apart from filling balloons that you might have studied in your general classes because it is light and it is incombustible, does not catch fire. The next one is almost there, 210. Which of the following is correct about neon? Most of the neon bulb or neon whatever, I've already said it all. They are used as what? Bulbs, neon light, neon bulbs. So in both discharge tube and fluorescent tube. So neon are used majorly as bulb. I have issues with writing now, so I can continue. They are used as well in discharge tube, in fluorescent tube. In botanical and greenhouses, gas greenhouse effect, we use the neon bulb. So most of the uses of neon are for bulbs and what discharge. Discharge. No, 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 no. No, 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 no. I think I'm slipping on by. Neon are used basically for bulbs. Please note that. Yes, yes, and they can be used for discharge tube, bulbs in discharge tube too. So all of this is correct, not one. All of them are correct. So this is the answer to the question. Then the next one we need to talk about, we've talked about helium, neon. So the next one should be argon. So argon are basically used as for welding. All these INR, IMR, welding, electric arc welding, and stuff like that. That's the major work, which are basically what I think you guys should have learned in your. Which of the following is used in discharge tube? And we just talk about that now. Neon, right? Neon is used as that. The next one, which of the following noble gas is used in electric arc welding of this is the last question for today. So guys, electric arc welding, we talked about that. Then you think about what hardware. So that is the answer to this. So now you now ask me now, what about the remaining noble gases? What are they used for? That is the krypton. Helium sometimes can also be used for, they use helium sometimes to separate some compounds. Yes, because they tend to deviate away. So they can also be used as separation. Those are other things you can add to the knowledge of what I've explained. Now, krypton, xenon, they don't have a particular use, no particular use. So most of them are just used in what? To produce colorful light. So when you are asked questions, anything about radon, zecton, krypton, xenon, they are basically used for producing what? Discharge light, all these lightning, all these lighting effects and stuff like that. That will be your answer. So there is no particular definition of the use of krypton, xenon. So always keep that at the back of your mind. So guys, I'm going to stop here. I hope you enjoyed this section. If you do enjoy it, kindly share the content, drop down a comment in the comment section, like, and overall subscribe to our content. Thank you very much. I'll see you guys soon. Do have a wonderful time. Thanks. Anonymous.